Well, hello and welcome YouTube. This is Mr. Robinson with another Algebra 1 question and answer video. This is on week numbers 9 and 10 focused on polynomials. Week numbers 7, 8 were focused on polynomials as well, but of course it was probably some different material and of course there were some different questions. Okay, here's the layout. I have 9 questions that I'm going to go over here. Number 9 kind of has 2 questions in one, and obviously some have some more than that. Okay, if you ever want to get a question asked and answered online, here's the format and here's what you got to do. Number 1, you got to submit an assignment sheet with a question or questions on it. So of course, as you're in my class, you submit homework. Every 2 weeks, I ask you to ask me questions right here. Now, I filter through the questions. I don't bother looking at the names. I just look at the questions and then I say, okay, the questions must relate to the topics in the weeks that are being covered. And I will select up to 10 questions to answer. Now, as you can see, there are 9 that I'm going to answer this time because there wasn't really a good 10th question that I thought was worth answering on a video. Not only that, but question number 9, like I said, kind of has 2 questions in one. So to me, I feel like that's answering 10 questions there. Those who get their question selected will receive a 6 out of 5 on their question for that 2-week period. Now, there are, for some of these questions, there's more than one person who asked it. So there's more than 9 people who are possibly getting that extra point there, that 6 out of 5 there. But hey, without further ado, let's go ahead and get started. And we'll start with question number 1 here. And the first question that's being asked is, what do you think about the diamond method? Why or how is it easier to do it your way? Okay, so if you don't know what's being asked here, this particular individual asked about something called the diamond method, which I know that this student does, and I know some other students have learned it as well. What the diamond method is you draw a diamond and then you have a little x between there. You split it up into 4 portions. Some people just go ahead and just draw the x here. And this has to do with factoring. If you have some sort of x squared plus bx plus c quadratic trinomial that's ready to factor, you write in the c up here and you write the b down here. And the numbers that you try and find are the 2 values that of course multiply to the top, that's the product, and they add to the bottom, that's the sum. So you're doing the same thing as you would do what's quote-unquote my way, which is just asking the question what 2 numbers multiply to C and add to B, and you try and find them out. And of course, you can do the same thing over here. Now, what if it was an ax squared plus bx plus c? Well, at that point now, the product at top, if you remember, is a times c. It's no longer just c. And of course, as this just says c, it was really 1 times c because this was a 1 in front of here. So now it's a times c over here, and it's still b down here, and you still try and find out your 2 values. Again, the 2 values that multiply a and c and add to b. So just for a quick example, let's say we have x squared plus 10x plus 24. Over here you would write, in the diamond, you write a 24 on top, a 10 on bottom, and you try and accomplish what 2 numbers multiply to 24 and add to 10. If you do what I do on the side, maybe you start to write some numbers down for 24, like 1 times 24, 2 times 12, 3 times 8, and 4 times 6, excuse me. And then 4 plus 6 is the one that gives you 10, as those are both positives and such. So to answer this individual's question, what do I think about the diamond method? Well, I mean, I think it's just some visual aid that somebody made up, and then people decide to follow it, and they say that it's the process they're going to choose. Why is it easy to do my way? It's not. It's the same exact method. We're still trying to find the 2 numbers that multiply to C and add to B. Now, here's what I do want to say about the diamond method. And this isn't saying it in any sort of berating or condescending way. But the fact that you're asking this question and you think that my way is different ends up being a little bit alarming, because you see the diamond method is quote-unquote my way. And again, all I do is I just ask what 2 numbers multiply to this and add to this. And you're doing the same thing. So the fact that you don't know that it's the same thing kind of becomes an issue. So what I think about the diamond method is it's a process that people just follow, and if they can't get themselves outside of the diamond, if they can't think outside of the diamond to do these problems, then that in itself does become a problem when it comes to solving these. Because you see, I do this mentally. You know, when people spend the time to draw the diamond, which doesn't take too long, but they spend the time to draw the diamond, they write these numbers here, and then they come up with the answer because they need this visual. See, you get stuck and reliant on that. And so what I think about the diamond method is just like FOIL. It's good training wheels. It's a good start for something. But then you got to learn what, in essence, you're actually doing. So, you know, with these problems here, if you can't find any other way to do them, I suggest you consider practicing it more. So that's why I never taught it in class, because I didn't want you to be overly reliant on it. Same with things like factoring and the generic rectangle, which, by the way, I did mention in a video. That being said, now that you've heard the diamond method, I'll bring up this diamond every so often here, but don't get over-reliant on it. Understand what it is that you're asking when you're drawing this. It doesn't do anything different than what we're doing when we ask what two numbers multiply to this and add to this, and then just go on your way. So the reason why I think mine's easier is because if I can mentally do it, I'm just going to write it out straight up. I'm not going to draw all this to make it happen, and I don't have to rely on it. Otherwise, there's no difference. They are the same thing. Good question, though. Thank you for asking. All right, now we're going to go to question number 2. And this question asks, when factoring with b and or c being negative, how do I know which signs I should test? So what this question is asking here is, when you have your x squared plus bx plus c or something like that, here, let's do this example. When you have x squared plus 10x plus 24, the thing is that both b and c are positive. So as you have a positive product, you know that it's either a positive times a positive or a negative times a negative, but because the sum is positive, you know that both your factors are positive. And we just found them last time, they were 4 and 6, and this is what it becomes. And straight up, it's pretty easy, because the signs are just both positive. But what happens when b or c are possibly negative, or when both of them are negative? What do you have? So I'm not going to write all these out, otherwise that'll take up a lot more time, but hear me out, please. And I'll be changing these along the way. Yeah, let's just go with this example. What if b was negative when c was positive? What if in this condition we still have a positive product but a negative sum? And thankfully this still works out with what I do. Well, if the product is positive, that still means either both are positive or both are negative. But because you're dealing with a negative sum, that means the only numbers that you will test are sets that are both negative. And you should test all factors of 24 with all of them being negative and figure out which one works. Thankfully, in this case, it's just x minus 4 times x minus 6. And hopefully you get pretty good at that. If you need to look at this as a positive for a moment while you're doing your problems, and then you turn this into 4 and 6, and then you call it negative to make it negative 4 and negative 6, hey, you know what? If that's your method, that's fine. Whatever visual you need to understand that, negative 6 minus 4 is negative 10 and not negative 2, and that's great. That's fine. Okay, well, so now what if you have a negative product? What if you have a negative product here? And so you see, this is no longer that negative 4 and negative 6 that we're dealing with. Negative product and negative sum, and oh yeah, you know what? Good thing with this, it's still factorable. What kinds of signs are you going to test now with b and c negative? Well, you have a negative product. That means one of them will be positive, and one of them will be negative. See, a positive times a negative is a negative. 2 negatives is a positive, but a positive times a negative is a negative. Now, your 10 is negative. What does that mean? Well, if you know what you're doing with a sum, then you know you're technically doing a difference. This is, if this was 4 and negative 6, which it's not, that means you're doing 4 minus 6, which is negative 2, to get the value in the middle. So you see x squared minus 2x minus 24 equals this right here. And what I'm talking about with the negative here is the reason this became negative is because the negative number was larger. If the positive number was larger and the negative number was smaller, that would be a positive 2, and this would be a plus like that. So if I'm just going to answer the question as far as how do I know what to test? Well, as we're talking about b and c being negative, one's positive, one's negative, and because this number's negative, that means the larger of the two numbers that you choose will be negative. So when you pick your factors of 24 that we just saw before here, I'm going to do subtraction with these, and you might see that we just ran into the answer there. It's going to be 2 minus 12. That's going to give you that negative 10. So this will be a positive 2 and a negative 12 in that case. And that's how I'm going to test them. I'm going to test the negative numbers to be larger and the positive numbers to be smaller to get my negative sum. So what happens then if the number's positive right here with a negative product? Well, now the positive number will be larger and the negative number will be smaller. And guess what? Now we're looking at a positive 10 there. So it's just the exact opposite of what you had before. So in closing, I just want to say this one more time. If b and c are both positive, both of your factors are positive. If b is negative with c being positive, both your factors are negative. If c is negative, you're looking at one positive, one negative. If b is if b is positive, then the positive number is larger. If b is negative, then the negative number is larger. Now, we are going to run into a special case this week, and it says, what if b equals 0? What if you have x squared minus 36, which is x squared plus 0x minus 36? Well, your b's are additive inverses of each other. They're both the same size, one positive, one negative. That would be x plus 6 times x minus 6. We'll get into that this week. Okay, question number 3. If a is negative, does it factor out to -1? So the question that's being asked really is, if you're looking at a quadratic trinomial and your quadratic coefficient is a negative value, should we factor out a -1? How about, does it factor out a -1? Well, the answer is yes. The answer is yes, it does. And this is a great question, because let's look back at our previous problem here, the x squared plus 10x plus 24. Let's say that this was a negative x squared plus 10x plus 24. You want to factor this negative number out, because if you don't, you can't ask the same question, what two numbers multiply to 24 and add to 10, because we know that's 6 and 4, right? That doesn't just become x plus 6 times x plus 4. Now I know what you're thinking. Oh, we got to make one of our x's negative. No. See, if you do this, what happens when you FOIL this out? Yes, it's a negative x squared, but then you get a minus 4x, a negative x times 4, and then a plus 6x plus 24. This becomes negative x squared plus 2x plus 24. So not the same thing. It's not that. Then you're like, well, maybe we just got to make the other one negative. No, that would be x squared, or negative x squared minus 2x plus 24. So it's not that either. Then you say, well, you got to put the negative on the outside. Well, no, because that's foiling this to x squared plus 10x plus 24, and that means everything gets negative. So it's negative x squared minus 10x minus 24. So you see, the question that you want to ask, what two numbers multiply to 24 and add to 10, isn't the right question, because this is not a 1. It's a -1, but it's not a positive 1. So this is not how we want to express this. Instead, we want to factor it out. And when you factor out a -1, yes, that's the same thing as factoring out just a negative. So what happens is every sign changes. So I could instead write just as negative like that. And what I'm going to do now is I'm just going to ask the question inside here. Now that this is a positive 1, now I ask what two numbers multiply to -24 and add to -10. And we saw that before as x minus 12 times x plus 2, and this would be your answer right there. But you see, you couldn't get that until the negative was factored out here first, because you can't ask that question unless this is a 1. Okay, so there's that. Now what if instead of this, let's say I doubled all this. Let's say negative 2x squared plus 20x plus 48. What if it looked like this instead? Well, you can still factor out the negative, but it's recommended, of course, that you also factor out that 2 from all of these things here. So don't just factor out the negative, and also don't just factor out the 2. What if I had this one? Or what if I had this one? Okay, I think this one will get you into less trouble, but I don't think you're going to end up factoring it all the way. I think this one you'll end up factoring wrong. Neither of these are any good. Factor out both. Factor out the 2 and factor out the negative. Factor out a -2. And you'll get back to your x squared minus 10x minus 24. And you can, of course, factor that out the same way. But this -2 does stay out here. So does it factor out a -1? Yes. You want to be able to factor that thing out here. Now let's say instead of this saying 48, let's say it said 50. No, you know what? That's still factorable. No, it's not. Let's say that said 50. So I factor out this thing to say 25 here. Now this is not factorable. I thought it was. I thought it would be x minus 5 times x minus 5, but that's a negative there, not a positive. Okay, this is not factorable inside here. Now you might have learned that when something's not factorable, you say not factorable. But the problem started right here. So we go to here, we factor out the -2, this would be your answer. No, it's the quadratic trinomial may not be factorable, but you factored your polynomial here. So yes, this was factorable, whether you factor out just a greatest common factor or you factor out a negative to get a leading coefficient. I will treat that as factorable. This may not be easy to solve still when it's set equal to 0, but that's not what it's asking if it's factoring. So if a is negative, does it factor out to -1? Do you factor out a -1? Yes, you factor a negative out. If your leading quadratic coefficient, your leading coefficient is negative, factor it out. You'll thank me later. Question number 4. How can you tell if something is not factorable? What steps can you skip to make the process faster? This is a good question because I really always talk about efficiency. Now, you may every so often ask me the question, hey, Mr. Robinson, did I factor this right? Or, hey, Mr. Robinson, how do you factor this? And I might look at it and say, like, it's not factorable, Or I might write out a problem and I'll say, wait, that's not factorable. How do I know? Because I've done this a lot before. Now, I know that you just want that secret formula to make something faster and to go faster. And I hate to be that Debbie Downer here, but there's no easy way. There is a process, though. You just got to know your numbers. You got to know your numbers. And that means you got to know your times tables. That means you got to know your addition and subtraction, like really fast. You got to know familiarity of numbers, how an even times an odd is always an even, stuff like that. You got to be able to mentally store these values. If you want to do it fast, you got to learn some things about numbers. You want to know which numbers are prime, okay? And most of all, you just want to be able to understand how factors work as sums and such. Let's say, for example, this is kind of a weird example, but let's say you were asked to factor x squared plus 10x plus 1. And before you go off and you start doing things like drawing a diamond and writing a 1 and a 10 and testing numbers there, understand this. There's only one pair of factors that I'm going to look at here, which is 1 times 1. And 1 plus 1 sure as heck ain't 10. Because 1 plus 1 is 2. So I know automatically this is not factorable. The factors that are listed here are way too small for me to get a sum that's 10. Even if this was an 8. The largest sum I can get from this is 8 plus 1. It's still too small. Or even if this 10 was a 3. The factors that are listed here are just too small for what's going on with this 3. So some of them you might just automatically know are not factorable in that sense. Or here, let's put it this way. Let's say the sum is really small, x squared plus x plus 12. What are your factors of 12? 12 and 1, 3 and 4, 6 and 2. All of those added together are way too large to compensate for this 1x right here. This 1, way too small. Now be careful with something like this though, because you got to look at the signs. What if this was a negative 12? See, now you can do 4 and negative 3. 4 minus 3 is 1. 4 times negative 3 is negative 12. So be careful with your signs. So it's all about knowing your numbers, and it's all about being able to mentally process these things. Again, I know that you want to hear that there's this other great secret method to it. No, it's a lot of practice. It's a lot of familiarity and recognition. It's a lot of not really going through that process of, if you draw these diamonds all the time, I promise you're not thinking twice about the numbers you just did. There was a video that the last video that I did is actually on mental factoring, and I know question number 8 is on mental factoring for ax squared plus bx plus c. And the very last problem in that thing, it was problem number 18, I believe, there was a question, there was a trinomial to factor, and I had done a problem like it before, and I had recalled that I had done that problem. See, there are things where that you want to be able to remember how to do, and that's not memorization. It's just recollection. It's just understanding it that way. So how do you do it faster? You really got to know your numbers. So you got to practice a lot. You know how often that I'm doing things in class where I'm saying, try and do this without a calculator, try and do it without writing down, try and do it mentally. That's not to try and impress anybody with this and that. It's so you really practice your numbers. Okay. How do I know what 25 times 17 is? Well, I know that 4 quarters are in $1, so I know if I do 25 times 4, that's 1, times another 100, times another 4 would be 400. So 25 times 16 is 400. So 25 times 17 must be another 25, that's 425. I didn't do this where I'm just, multiplying all this stuff out here and then not have a second thought about what's going on there. Right? I'm not multiplying that way because you're not thinking about your numbers when you do it. So, practice this a lot. Get into familiarity. Start listing your factors of numbers. Understand what is prime. Understand how odds and evens work. Understand how I list numbers divided by 1, 2, 3, 4, etc. You'll get really good at this. So what steps can I skip? I can skip drawing a diamond. I can skip listing my factors if I practice mental storage. That's what you can skip. You can start to look at some of these and start to recognize, without asking the question, say, there's no way that can add to that. So that's a good way of talking about this. And I know that doesn't sound good to you because that means you have to work at it. But yeah, you do. You have to work at it. That's where you get good at this. Look, I'm pushing 30 years old right now. I've been doing this factoring since I took Algebra 1 in 7th grade. Okay, and then you keep factoring in every class outside of, I guess, geometry. You don't do much factoring, but you factor in every math class outside of that. And I've taught Algebra 1 for 6 years, and I've been, teaching every other math class for like over 9 years. I've been tutoring people. It's just, I've done this a long time. I've done it a long time. And if you do it for a long time, you'll get really good, but it starts with practice. It does. And practice makes permanent. Got to practice it the right way. Okay, question number 5. How do you factor with the zero product property? Okay, the question's kind of faulty. Now, I brought this one up exactly like this because 2 people wrote it like this. They're in different classes, so I expect that this was an independent question both people asked. It's more how do you factor and use zero product property? I'm not really sure what the question is that's being asked. I think some people don't really know what zero product property is just yet. Let's break down this property, and I know we talked about this one last time, so I'm not going to get in great detail, but let's really break down this property. It says if A times B equals 0, then A equals 0 or B equals 0. First of all, this is only true for products that equal 0. It's not true for sums or differences or quotients. It's not true for numbers that are not 0. This only works for 0. What this says is, as long as one number is 0, the result will be 0. This also says there are no 2 non-zero numbers that can multiply to become 0. So this is a property. This is something that you exercise and you use as a step, as a result of doing a problem. So I guess the real question is, how do you solve a quadratic equation? How do you solve a quadratic equation? Step 1 is by factoring. If it's written in standard form, you got to factor. And step 2 is use zero product property. These are just 2 different steps. So if you have a problem that's set up x squared, plus 10x plus 24, let's go back to this one, equals 0. This is set equal to 0, but this is not a product. This is a sum. This is this term plus that term. This is not a product. You have to factor it first. When you factor, you divide out. And when you divide out, the result becomes a product. I divide out an x plus 6. I'm left with x plus 4 there. When you multiply them to get 0, either this x plus 6 equals 0 or x plus 4 equals 0. And then, of course, you subtract 6 and subtract 4. So I don't really know what to say beyond this thing. The property itself, it's one of those pretty obvious ones, but it's one that you have to use the right way. You can't use it unless it's a product. You can't use it unless it's set equal to 0. By the way, this is an OR here. So I don't really know what else to say with that. Again, the question isn't really asked right. I want to make sure that you can ask the questions the right way. You don't factor with zero product property. You factor something so you can use zero product property. So I hope that answers that question there. Okay, question number 6 asks, how do you solve a quadratic equation that doesn't have 0 on one side of the equation? Well, it depends on what kind of question you're talking about. Yes, you're talking about a quadratic, but there are different kinds of quadratics. There are quadratics where if you have a constant written on the other side and you have the linear term like x squared plus bx equals c, there is a way to solve this set up like this. It's called completing the square. We are not focused on that in this chapter, so I'm going to get rid of that one. Don't try and do it that way. But there's something called completing the square. There's another way, if there is no linear term and it's written like this, and you can just take the square root of both sides, which of course I advise you don't do only because we want to focus on factoring and because you probably don't know that you have to look at the positive and the negative version of that square root value. So if x squared is 9, then x can be a positive 3 or x can be a negative 3 because of course you can square a positive 3 or a negative 3 and get positive 9. That's another one, but that's not really what you're asking. What you're asking is what happens when there's no 0 on the other side. You have x squared plus bx equals c, and you want to solve this thing. Move this c over. Subtract it. So x squared plus bx minus c equals 0. You set it equal to 0, and then you factor as you do. Now, if it's unfactorable, then at this point in time, from what you've learned, you would just say you would say no rational solutions. If it's not factorable, you can say no rational solutions. I know we're not really running into those just yet. But, let's say we have x squared plus 10x equals 24. Of course, I'm just using this example all day. Subtract that 24 over. Now it's equal to 0. Now, like question number 5, you got to solve by factoring. And in factoring, you can then use the zero product property because you now have a product equal to 0. See, this is an important step. You don't want to take the greatest common factor here, that is x, and write it like that, because although this is a product, this is not equal to 0. This is not the way to go. Not this way. Set it equal to 0 first and then try and factor. Even if you can find numbers that work here, like 2 clearly works here, I doubt you would find the other number, which is negative 12. So go this way. Yes, this way. Subtract and go. All right, question number 7. How many possible answers can you get when you factor? This is a good question. So not just when you factor, but what if it's already factored? What if it's not factorable? Let's just talk about this a little bit. If you have a quadratic, x squared plus bx plus c, something like that, equals 0, and you're trying to solve, and you factor it to some sort of x plus p times x plus q, I'm just making up letters there, equals 0, and you get x equals negative p and negative q, whatever. If you have a quadratic, you see this degree 2? That means a quadratic can get up to 2 solutions. You can see it in the polynomial when it's written in standard form. You know where else you can see it? In factored form. How so? Take a look at your variable x, wherever it appears. Take a look at the degree of each of those and count those up. See that 1, that 1? 1 plus 1 should give me 2 here. Because this kind of leads to a lot more questions and things I want to answer to this. When you see things in factored form, you should be able to know what kind of degree, not just what kind of degree it is, but what kind of, what kind of degree. It's a quadratic, degree 2. Because there are 2 x's involved. Now, if there's, that's this one, so up to 2 solutions. Now, what are cases in a quadratic where you don't have 2 solutions? Because I said up to 2. You could have 1 solution. How so? Take a look at this example. X squared plus 6x plus 9 equals 0. Now, this factors to x plus 3 times x plus 3. It's one of those special cases. So it's the same quantity twice. Yes, it's a quadratic because it's x to the first, but they're both the same solution. You get x equals negative 3. This is said to have a multiplicity of 2. That's because you can also write this as x plus 3 quantity squared. It multiplies by itself twice. But there's only 1 solution. So it can have less than 2 solutions. It can have 2, 1, or it can have 0. We saw like that x squared plus 10x plus 1. It's not factorable. And not only, oh, no, you know what? Here, let's not do that one. Let's do x squared plus x plus 12 equals 0. This is not only not factorable, but there are no real solutions to this thing. Sometimes they have no solutions. Now this one has what are called imaginary solutions. We're not going to deal with those, at least not so much in Algebra 1 topic. It's more Algebra 2, but no real solutions here. So if a quadratic is here, you can have 0, 1, or 2 solutions. Now, how did I see this as a quadratic? Well, because the 2 here, or in factored form, you see those guys. Now, what does that mean for anything else? Because this is a great question. How do you know how many solutions you're going to have? Well, not that, but how many possible answers can you get? Well, what if it's a cubic? If it's a cubic, you'll have up to 3 solutions. Now, I'm not going to show you one in standard form, the cubic, because I'll have to come up with it. But let me show you one in factored form. What if we have x plus 2 times x plus 6 times x minus 1 equals 0? See, this is already written in factored form. You might know this has 3 solutions, and I hope you do. But did you know that this was a cubic? Did you know this was a cubic polynomial? See, eventually, say I foiled these 2 things right here, and I got x squared plus 5x minus 6, and I didn't yet distribute this one. And now when I start to distribute this one, what's the first thing I'm going to do? X times x squared. What does that give you? X cubed. So you see, as long as there's an x here, an x here, and an x here, eventually they're going to multiply. Eventually they're going to multiply. So you should recognize this is a cubic off the bat. That way, you can answer that question, or you can be able to expand it out and know that you did it right. Or if you have an x cubed, here, let me give you an x cubed that'll give you two solutions. X cubed plus 10x squared plus 24x equals 0. No, I beg your pardon. This is three solutions. Take a look at this problem. I can pull out a common factor of x, and then, of course, factor that part out. And there are my three solutions, either x equals 0, x equals -4, x equals -6. But the point is, a cubic can have three solutions. One could have two solutions. If I have something like, hang on, I have to think about it. If I have something like x cubed minus 9x squared equals 0. Now I factor out an x squared, and I'm left with x minus 9. See, this either x squared equals 0, therefore x equals 0, or x minus 9 equals 0, so x equals 9. So you can see in this kind of instance, there are two solutions for the cubic, but a cubic can't have more than three solutions. It can have 0, 1, 2, or 3 solutions in the same way. A quartic can have 0, 1, 2, 3, or 4 solutions, all those kinds of things. So how many possible answers? It's based on the degree. It's based on the degree. That's why all linear, like x plus 2 equals 4, that's why all linear ones can have 1 or 0 solutions. What if it said x plus 2 equals x? Well, this is no solution. So anyway, a linear can have 1 or 0, a quadratic can have 2, 1, or 0, etc., etc. The other thing I wanted to mention was in factored form, I should be able to know what kind of polynomial this is. This is a cubic. What is this one? If we multiplied this out, eventually the x squared would multiply with the x, and with the x cubed, that would be x to the 6th. This is a 6th degree polynomial. So I can look at it in factored form and know what kind of polynomial it is. That's another big part about this. Okay, question number 8. How do you do mental factoring on ax squared plus bx plus c when a doesn't equal 1? So I'm going to point to two previous things here. First of all, I'm going to point to this previous slide. Know your numbers mentally. I'm telling you that there's a mental way to do it, and I want you to learn how to do it if you're feeling really good about doing the other ones successfully. But you got to know your numbers mentally. So right here, so know numbers mentally. The other thing you want to know how to do, and this is based on the other thing that I got to point to here, is you got to really understand FOIL. I know that you know FOIL, first, outside, inside, last, but you really got to understand it and what happens when you distribute things. Because when you do mental factoring, it's really doing the backwards process, and you're really distributing. Okay, you're really distributing when you do it. And so the other thing I want to point to is there's a video, the video before this one. If you go to my channel and you see this video here, the one we're talking about right now, the one right before it involves mental factoring on these kinds of things. And I go through a bunch of examples on those. What I didn't do, though, was I didn't write out all the possibilities that an answer could be. So what I'm going to do for us right now is I'm going to go and do at least one example, maybe a second one. But I'm going to do at least one example. I'm going to turn my wireless back on, airplane mode off. And what I did was I pulled up a page here. Now, I promise I didn't look at these yet. And a lot of these are kind of big here. But if you can, if I can prove to you that I won't know what's coming up here, I'm going to go ahead and refresh. I'm going to go ahead and refresh this page, and these will randomly generate again. So take a look. Randomly generated. Okay, let's go ahead and take a look at one of these. And I don't want to get something too large. Let's take a look at this number 2 here. Let's start with number 2. 8z squared minus 6z minus 20. I got to factor that. Okay, let's factor 8z squared minus 6z minus 20. And let's do it mentally. Now, the first time, I guess I'll do this twice. When I do it mentally, I'll write out what it is that I mentally do. And then the next time I'll see if I can talk it out and help you out that way. Okay, for starters, there's a common factor. If you don't factor that out, then it's going to make this problem so much harder to do. Because you have to get that common factor anyway out of there. So that's important. Okay. Now, this problem isn't very easy to do mentally for several reasons. Number one, your quadratic coefficient is what's called a composite number. It means it is not prime. Number two, your constant term is also a composite number, which means it is not prime. And number three, you have a negative product. Now, number 3 is not that bad, and I'll explain why when I list out all possibilities of what factors here. Okay, how does this thing work, the mental factoring? First of all, if it's factorable, that means its appearance will look like this. 2 times blank times blank. That's what I know for sure. I also know that there will be a z here and a z here. As this is a quadratic, I know for sure that is. Now here's where everything changes. So I'm going to copy and paste this thing a couple times here. I'm going to at least get 2 set up, because here's what's going on here. And you know what? So I will write this to begin with when it comes to mental factoring. I will write this to begin with. Here's what happens next. 4 can either be written as 2 times 2, or 4 can be written as 4 times 1. So this is what makes this a little bit harder when this number is not composite, or when it's not prime. When it's a composite number, you have to test a lot more things. Now, with the 10 being composite as well, you have multiple things to test there too. And you know, with this positive negative stuff, again, I will play with that and kind of show you what's going to happen here, but you do know that one's positive, one's negative. I'll show you why I'm actually not going to do all the things here, and that's why it's not that bad, but you got to know numbers for this to work. But let me show you what I am going to test here. I'm going to test 8 combinations. Now, I'll stop if I find my answer, or I'll stop if I find the opposite sign of this. And by the way, I'm not thinking through this problem right here. I'm showing you what the mental process entails. You got to mentally be able to distribute. Now, 10 can either be 10 times 1 or 2 times 5. But which one is negative, which one's positive? Now, I know you see that this is negative, so you might be saying out loud, oh, that means the larger number is negative. Not necessarily true, because you have to understand that these are multiplying by other numbers here. See, when you FOIL, this is why you have to know FOIL. When you FOIL, you have to understand that this number, this negative 1, is about to be doubled by this 2. When you FOIL, this happens. This, then that. That becomes a negative 2z, and this becomes a positive 20z, and this, and that, and that. So you have to understand those numbers are being doubled. Now, because they're both a 2, yes, that does mean I should only choose the negative one. So I will show you why I'm not going to choose certain problems here. So 10 times 1 is 10, and also 5 times 2 is 10. So those are ones to test. Now, I'm going to drop you a little hint right now. I know that if this is factorable, none of these are the answer. I'll tell you why later, but I know that none of those are the answer. And it's not because I didn't FOIL, or it's not because I already FOILed. I already know none of those are the answer. So I know one of these are, and by the way, when I created this thing here, all of these are factorable. I did a checkbox thing. Here, I'll even go back. I created this thing right here. Don't include non-factorable polynomials. Let's do all of them greater than 1 and blah, 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 blah. So by the way, this thing is going to generate a new set of problems here. So I'll be sure when I do a second one to do that. But anyway, I know this is factorable for sure. If it wasn't factorable, yeah, this would be a little harder to do. Okay, anyway, over here you'd be testing exact same things. Now, I don't actually write all of these things out. You know what I only write out? I just write out the 2z and 2z, and then in my head, I'm testing all these numbers. So here's how I test it in my head, because I'm not going to write this out loud. We know the first one's 4z squared. We don't have to worry about that. We already know 10 times negative 1 is negative 10. We don't have to worry about that. In FOIL, we have to just worry about the O and the I. 2z times negative 1 is negative 2z. 2z times 10 is 20z. Negative 2z plus 20z is 18z. Clearly, that's not negative 3z. That's not the answer there. Now, here's how I know this one's also not the answer. Because this is going to give you negative 18z in the middle. Take a look. What did we switch? Just the signs of these two things right here. They're still multiplying by 2z's. This would give you 4z squared minus 18z. Blah, 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 blah. So let's try some of these. Negative 4z plus 10z. Whoops. Plus 10z. That is 6z. Nope, that's not it. And guess what this one would give you? Negative 6z. Now that's not how I knew that these weren't the answers. How did I know that these weren't the answers? Because this was an odd number. Now you're like, well, this is an odd number and that's an odd number. Well, guess what? They're multiplying by evens. An even times an odd is always even. An even times an even is always even. Therefore, no matter what we multiply, we'll be doing an even plus an even no matter what we do. And guess what an even plus an even is? It's always an even. So that's the thing about knowing numbers. You got to know numbers if you want to start to filter things out. That's why none of these can be the answer. All I would get are even numbers. So I wouldn't even try these. I wouldn't even try them. It's great, right? I halved my numbers here. I halved my numbers here. So there are those ones. Okay. So now let's try these ones here. 4z times negative, that's negative 4z plus 10z, which gives you 6z again. So that one doesn't seem to work. Now, this one is kind of an issue as well. See, this problem here will be no good, and this problem here will be no good. And let me tell you why about these two. Besides the fact we multiply this, we get an even. It's because this had a common factor of 2 still involved. This has a common factor of 2 still involved. You don't think that if we already knew that this would have a common factor of 2 to start with, we wouldn't have pulled that one out? You think that if we would have pulled out that other factor of 2 to begin with, it would have made it easier? We would have. The fact that this has a common factor of 2 means this can't be the answer. And of course, this has the even times the odd thing, which gives you an even as well. So it can't be those. So it's just one of these two. Now, which one is it? Both these give you negative answers, so you just try them. Well, that's negative 40z. It can't be negative 40z, so it must be this one. And I'm not even going to test it. It must be this one. Well, I'll test it after the fact, but I'm saying I know it's got to be this one. So that's negative 8z plus 5z. That is negative 3z, so it looks like that's the answer. So, when you do mental factoring, I'm still taking things out before I even compute them. I didn't know this was the answer in the beginning because I wasn't thinking about it mentally. If I did, I guarantee you I probably would have tried this one or this one first, and once I tried this one, I realized that wouldn't have been the answer. All the other ones would have given an even linear term. So that's one of those things, and I know this really slows down this video when I talk about this one, but if you're going into this and if you're asking this question, which the person who asked, I want you to try this. I know who you are. I want you to try this. That's how it works here. Now I'm going to go ahead and do another one. I'm going to erase all this. There's one other thing with this thing, and it was, this one's clearly obvious. Once you've kind of multiplied one of them, if I'm going to multiply 4 by something, and I'm trying to get a small value here, this number I multiply 4 by better not be large. See, 4 times negative 10 is negative 40. I know I'm not going to get a right answer by multiplying a 4 by a large number there. So I'm probably just not going to try it. That's knowing your numbers. See, that's knowing your numbers. Let's go ahead and take a look at another one. I'll refresh this page. I want to get one with I don't know. I'll take one as it is. A lot of these have common factors here. Did I choose something that gave me common factors as well that I didn't want? I don't want all those big things. Trinomials, first term greater than 1. Don't include non-factorables. No. Include monomials. No. I don't know. So I guess I'm going to have to pull out some common factors here. That's okay. I'll do that. Let's do this one right here. 6. 12h squared. Okay, 12h squared plus 3h minus 15. Because, you're not going to be given huge ones. See, if they get too big, then at some point you throw in the towel, Okay, let's go ahead and factor this one here. First of all, common factor of 3. You pull that out, it's going to make things a lot easier here. Plus h minus 5. Now again, 4 is a composite number. 4 is a composite number, so when I write these things out, it's either going to be 4h and h, or it's going to be 2h and 2h. Now, what did I just tell you about the last problem that we had? This is just lucky. I didn't choose this because of this. In fact, I wanted to choose another problem for a different reason, but this is a 1. It's an odd number. These have two evens that are going to multiply by another number. An even times any other number is an even plus even is an even. It can't be these. So there are only 2 real sets of numbers that I need to test here. First of all, plus or minus, because a negative product. It's either going to be 5 and 1. Oh, you know what? And I didn't say something about the last set of problems. I should have. I sort of did. I'll talk about it here. It's either going to be 5 and 1 or 1 and 5. Now, this might not be one of the only This might not give us our answer. Okay, it does give us our answer. Well, let me do this. Let me change this. Sorry about that. Let me change this to a -5 and +1 like this. These are the only two ones you need to test. Okay, and here's why. This one here, this is going to give you 4 times 5. Forget about it. That's a 20. We're not going to get to 1 with a 20 there, -1. Yeah, that's not going to give us it. So it's got to be this. Now, it's not that this is the answer, but take a look at this. 4 times 1 is 4. 1 times -5 is -5. So 4h minus 5h is negative. Let's see, 4, whoops. When I distribute this, this will be 4h squared minus h minus 5. Now, that's not the same thing as this, but what's the difference? What's the difference? Is that if only this were positive and this were negative, that would give me my answer. So all I need to do is look for the thing that gives me really a 1 or a -1. I need to find the one that gives me that difference. The fact that 4 is going to multiply with a 1 or -1, and the 1 here will multiply by a 5 or -5, will give me the proper difference between the two numbers. They'll be separated by 1. The question is which one makes it positive or negative. So as this one made it negative, then clearly the answer must be 4h plus 5 times h minus 1. So that would be the answer there. Now, again, I didn't have to test much. I only had to really test one, and then I got the other answer from here. This one, I did a minor test. 4 times 5 is 20, forget about it. These I didn't need to test. So they don't always work out so great there. And, I'm not going to do one more, but I'm going to just set up one more just to tell you something about it. I want to get a positive product. Okay, this one, even though I don't really know what the greatest common factor is here, probably 10. So 8h squared plus 260h plus 210. 80h squared, I'll do this one. I'm already over time. Let's just go ahead and do it. Plus 260h plus 210. Well, I know these can divide by 10. So I can factor a 10 out. And that's about as much as I can go. No more common factor. So bad news first, composite number right here. That means I am going to have to list some primes and that'll happen. The good news about this is the positive product. And the reason why that's good news is because as I know this will have an h and h, and I'll have to test some values here, I know these will both be pluses. Okay, so I won't have to deal with minus scenarios here. Okay, so let me do this problem as I really would. Okay, let's go ahead and try 8 and 1. And I'm going to try factors of 21, either 1 and 21 or 3 and 7. 8 better not multiply by that 21 or by that 7, because that'll give me something that's larger than 26, and that can't be possible. So I can try a 3 here and a 7 here. That'd be 24 plus 7. That's not going to give me it. Or I can try a 1 and a 21 here. That's going to give me 29h. That's really close, but that's not the answer. So it's not 8h and 1h. Boom, I can take those ones out. Let's try 4h and 2h. And guess what? I should try them because this is an even number now, as these are evens. So, same thing as before. I shouldn't try a 7 or a 21 here because 4 times 7 is 28 already. It's too large. So I can try 3 and 7, which is 12 plus 14. And guess what? There it is. That's my answer. And I just did that as I would. Obviously, I talked it out through with you, but I solved it. I didn't have to find out what two numbers multiply. What's 8 times 21? 168. What two numbers multiply to 168 and add to 26 and then factor by grouping and then all that stuff? No, I got my answer there. Hopefully this last one started to convince you that, hey, I'm making sense of what's happening here and how you're testing your numbers. It's making sense. And by the way, that 10 needs to stay outside here. Okay. So to answer your question, you got to know numbers mentally and you got to understand FOIL. You got to know how these things work. But that doesn't mean you can't practice these things. But that's what it takes. That's what it takes. And the final question, how do you express the area and perimeter of irregular shapes as polynomials? Well, if you're asking this, you're probably talking about, remember the one we had on the test. You have a pool, and I know it's drawn differently, but the classic L shape. You have the pool. You're only given certain values. What do we do to find area and or perimeter? Well, let's talk about area first. If nothing else is drawn, give yourself something that you can find the area of that's more regular. You can do a rectangle. You can do 3 rectangles. You can do 2 triangles down here. You can make two trapezoids, whatever you know how to find the area of, divide it into that. In this case, I would say two rectangles. And if we're talking about the pool problem that we talked about on the test, which isn't drawn exactly like this, but it was already divided for you into two rectangles. Now, what do you do with those? You take the area of one, you take the area of the other, and you add both of those areas. The area of one plus the area of the other equals the area of all. You know what else you could do? So you could extend this out here, find the area of this entire thing, find the area of this small guy here, and subtract this area out of the area of the big guy. I know we didn't talk about that on the test at all. You absolutely could have done that. Yes, you could have. So, you have options on what you can do for that kind of stuff. Okay, so that's for area. And, I'll break this problem down as the test problem was to talk about perimeter. Okay, how do you find perimeter? Well, you add up the lengths of the sides, but the real question is how do you find the lengths of all the sides based on what you're given? If I recall correctly, and I know it's not drawn exactly the same, but there's a 5 plus x and a 5 minus x. This was an x, this was a 2, and that's all you're given. Well, if these are drawn as rectangles, you got to know how your shapes work. And one thing about rectangles is opposite sides are equal. So if this is a 5 minus x, this is a 5 minus x. If this is an x, then this is an x. If this is a 2, this is a 2, but the problem is we're not dealing with this part of this side because that's not one of the outside lengths here. So the last one we need is this one. And if you think about it, this length is just taking this length here, the 5 plus x, let's see if I can drag this thing, the 5 plus x here, and taking away this 2 right here. What if I take 5 plus x and subtract 2? Well, you get 3 plus x. So this becomes 3 plus x there. So you find the perimeter by adding all those up. And if memory serves correctly, the perimeter was 2x plus 20. I'm just going to write that out. And the area, I don't really remember the area. It was 2 times x, the area of that. 5 minus x times 5 plus x, that's a difference of 2 squares. That's 25 minus x squared. So it'll be 25 minus x squared plus 2x. And if you write in standard form, it would be something else. Yeah, so there's that. And, so that's how you find irregular shapes. The area and perimeter of irregular shapes is polynomials. You got to, you do the things I talked to you about. Know your shapes and work things out. Break them into shapes that you know. Now, one other thing you didn't ask is, what if they say, oh, x equals 3, so, find out the area and perimeter. Well, don't plug them into these things here and recompute them. You already have expressions for perimeter and area. If x equals 3, then this is 6 plus 20. That's 26. If x equals 3, that's 25 minus 9 plus 6. That's 22. So, I'm done. I don't have to recompute anything here. Once you have expressions, that's why you use them, right? That's why we're doing this in the first place. That allows you to simplify everything that you have. Now, you won't always have problems that look like this. What if you have one that looks a little stranger, that's like I don't want to do just a trapezoid, but let's say it kind of looked like this. Well, you can break it up into a triangle and a trapezoid. Anyone know the area of a trapezoid? If you don't, that's okay, because you can make this another triangle here. You know the area of a triangle? I sure hope so. Half the area of a rectangle with the same base and height. So boom, you can do that. What if you have one that looks like, oh, here's one. What if you have one that looks like this? Not an arrow. That looks like this right here. And let's pretend like you know that that's a half circle. Well, let's break this up into a rectangle and a half circle. And you got to find the area of a circle and divide it by 2. And then you add it with the area of a rectangle. How do you find the perimeter? You take the lengths of these 3 sides and you take half the circumference of your circle. So, the shapes won't get so irregular like this and you won't know what to do with it. You'll be able to break them up into things that you know, and that's the whole point of that. And then you got to be able to express these things in terms of what you do know as well and how differences are made, especially the rectangle idea, that this length of 2 right here is also that length right there. So you take that out and you get that. Things like that are very, very important. All right, so those are all the questions there. That was 1 through 9, and I know, of course, I ran over time, but, of course, I also wanted to dive into some of those other things in a big, big way, and I sure hope it was very helpful. And, of course, you're always just looking at the questions that you need to know the answer to, or what have you. This is always supplemental, not required. This stuff is required to know, but it's not required you need to watch this. But, of course, if you're hearing me right now, then you probably already just watched the whole thing. Well, this was great stuff. I hope that you ask some more enriching questions along the way, and as always, stay classy, guys, stay awesome, and have a a great rest of whatever day you're watching this, all right? Have a great rest of that day. Baseball season's coming up soon. I hope that you're going to start to enjoy yourselves a little bit more, that we're jumping into the spring. All right, see you later. Fiend!